Greetings everyone, welcome to video number 40 in the project management series presented by Process Geekoid. Today's agenda will be going over reviewing the PMBOK process table as well as the 37th process, which is the perform quantitative risk analysis process. This process occurs at the intersection of the risk knowledge area and the planning process group. As always, please subscribe, like, and comment. So let's move forward. So after planning for, identifying, and prioritizing all possible risks, the next step is to analyze the possible cost impacts of the risk, whether it be a negative risk or threat, or positive risk or opportunity. In the perform quantitative risk analysis process, this is where we numerically assess the risks using the following tools, such as tornado diagrams, which is a measure of sensitivity analysis, Monte Carlo simulation, which is a computerized simulation that uses 3-point estimation, and cumulative expected monetary value or EMV analysis that sums up all scenarios with probability times impact. We do this for EMV or expected monetary value by multiplying the probability of occurrence with the cost impact, and the cost impact will be positive for opportunities and negative for threats to arrive at an expected monetary value analysis to see which scenario reaps more benefits. The higher the EMV dollar amount indicates we should embark on the project, and lower the EMV indicates the project with more downside risk is going to be sidelined or put aside since we'll be losing money. In general, we want to minimize threats and maximize on opportunities. In other words, we want to go after projects that have higher expected monetary value and return rather than the projects that have lower negative EMV values and losing money. So we want to gain money and profit on the project, so we need to go after projects with higher EMV. The key benefit of this process is it produces quantitative risk information to support decision making in order to reduce the level of project uncertainty. This slide is recapping what risk management is, and so far we have planned for risk management, we have identified the risks, we have prioritized the risks in perform qualitative risk analysis. Then now we're at the stage where we're going to take our prioritized risks and assign a cost impact to them in perform quantitative risk analysis. Next, we have the ITTOs, inputs, tools, techniques, and outputs for perform quantitative risk analysis are shown here. For inputs, we have risk management plan, cost management plan, schedule management plan, the risk register, which is an output coming from identify risk process. It is also a project document. Then we have enterprise environmental factors. This could be in the form of industry studies of similar projects by risk specialists and risk databases that may be available from the industry or proprietary sources. Then you have OPAs, organizational process assets. These are policies that assist in quantitative risk assessments, such as templates, formulas, and risk ratings. Next, for tools, we have data gathering and representation techniques. This could be in the form of interviewing and go and ask questions to draw on experience and historical data to quantify the probability and impact of risks on project objectives. So an example of this is to use a probability curve that shows the beta distribution and triangular distribution, and this can be shown here in this slide. This is what we're looking at. Basically, any probability distribution curve has a maximum probability of 1, and the most commonly tested one is going to be the beta distribution. So essentially, we'll be using that in the data gathering and representation technique. Then you have the next tool, which is going to be quantitative risk analysis and modeling techniques. This could come in the form of sensitivity analysis or tornado diagrams, and that is going to be looking at something that looks like this. Basically, we have probability, which is a percentage, times the impact, which is in dollars, for risks and opportunities. For positive risks or opportunities and negative risks or threats, basically the dollar amount is going to be negative for a risk or threat and positive for opportunities. So we'll be multiplying the probability times impact to get the value. So on the right here, you see the positive impact and the negative is in gray. So it shows that we'll have to go over and maximizing the use of the positive risks, which is risk 1 here, and risk 2, and risk 3. These 3 look like we should go after them to reap the benefits. That is why we're using a sensitivity analysis diagram, which helps us to determine which risks have the most potential impact on the project. It also helps us to understand how the variations in the project's objectives correlate with variations in different uncertainties. So this is how we're doing it. We're going to focus on the ones that give us the most value, and the things that have more positive value are the ones we're going to go after. And another tool and technique is going to be the quantitative risk analysis and modeling techniques, and within that we have expected monetary value, and that can be used in the form of a decision tree. Here we're going to have the probability times impact, and here you can see that the path on top here has the highest expected monetary value in return. So here we take a decision to build or upgrade. So now we look at build versus upgrade and take the dollar amounts times the probability, and we get 60%, 40%, multiply that by the actual demand value, and by multiplying all these values we come up with the highest value. Out of all of this, we see that $80 million is the highest value, so we would go with the above path in the tree diagram here, decision tree diagram, and say that we would want to build rather than upgrade, and we'll get more benefits that way. So that's how a decision tree is going to be used in conjunction with the expected monetary value formula, which is probability times impact. So you see that right here, probability times impact, you sum up all those values, and that will give us a net value that we'll be going after, and that tells us the $80 million value is we're going to build the new plant, and that will give us more benefits. And then next you have the next tool and technique is going to be expert judgment. And this is coming from prior projects, project management office guidance, and risk management professions, and business continuity management teams to guide in quantitatively analyzing our risks. And next, the major output from this is going to be project document updates. Updates to the risk register is prioritized, and basically you're going to now assign a cost value and update that, and putting a prioritized list of risks that have a dollar amount attached to it now, and other documents. So here we'll also be updating in the project documents the probabilistic analysis of the project, the probability of achieving cost and time objectives, the prioritized list of quantified risks, and the trends in quantitative risk analysis results. So the key benefit of this process is it enables project managers to reduce the level of uncertainty and to focus on high prioritized risk items. Next, this slide is just going to recap the probability distributions. And note, regardless of the type of probability, the maximum probability of an event occurring is 1 or 100% and can be also verified with calculus through the use of integrals. Integrals are used to determine the area under the curve, and in a mathematical proof, their area under any probability curve is going to be 1. So note that on the PMP exam, it's going to focus more on the beta distribution. Next, we'll be going over the decision tree tool, and where the decision tree is a tool used to decide using a tree graph model of the decisions and their possible consequences, including chance event outcomes, resource cost, and utility. In this case, it shows the cost outcomes based on the questions such as do we build or upgrade. So the higher the expected monetary value coming from probability times impact leads us to select the top path with the net path value of $80 million shown here. We're taking the probability times impact, and we sum up those probability and impacts. That gives us $80 million. So this helps us automatically focus attention on getting more bang for our buck. And next we can see here is the sensitivity analysis tool, or also known as a tornado diagram. You can see the diagram here looks like a tornado. We're basically taking to see the sensitivity or the reaction to the different risks and what the impacts look like. So here we see that we can focus on risk 1, 2, and 3 in a positive fashion, where we're going to gain some benefit and use that as an opportunity and focus on that. And essentially, if there is a high risk or high threat item, and basically we will prioritize that as an action item and have an aggressive response. If it's a low risk or low threat item, we put it on a watch list and add a contingency reserve and have an active acceptance of this risk and monitor it. In the case of a high risk or high opportunity situation, we would prioritize it on the first and reap benefits of the opportunity. And essentially, we will always want to focus on high opportunity pieces. If we want to gain more money on the project, we need to prioritize and use our efforts towards maximizing on opportunities and minimizing on threats. And keep in mind that the beta distribution is going to be used in the quantitative risk analysis process more. And you can see that here in the Monte Carlo simulation. And this is a computerized simulation that uses the 3-point estimate, pessimistic, optimistic, and most likely. And we'll be using the beta or weighted distribution for the exam. Typically, you'll be given a formula with pessimistic, most likely, and optimistic values. And the Monte Carlo simulation is a tool that is computerized to give us values to determine which endeavor to go after. Thank you for watching this video. Please subscribe, like, and comment.